The next algorithm that we will build is called binary search. This is a widely known algorithm and is one that is implemented in many different forms throughout computer science. It is an essential algorithm to know because of its wide use, its popularity in interview questions, and its performance. A binary search algorithm allows a user to search for a given value inside of a list. Because of the way that binary search functions, it is very performant, running in O of log n runtime, or logarithmic runtime. The following video clip will explain what binary search is, how it functions, and why it is so performant. If you had a physical dictionary and you wanted to find a single word in that dictionary, you would find it by doing binary search, probably without even realizing it. Let's say that you are looking for the word house in your dictionary. You would open up the dictionary to the middle, and you would notice that you are in the M section. Well, you know that house will be before the M section, so we can totally forget about the second half of the book. So we just cut our input size, or the number of elements that we have to search through, in half. We are now left with the front half of the book, so we will go into the middle of this section, and we will notice that we are now in the F section. We know the word house will be after the F section, so we throw away F and everything before it. So we just cut our input size in half again. We are now left with sections G through L. We go to the middle of what we have left, and we wind up in section I. We throw away everything after I because we know house will not be in that area. We go to the middle of what is left, and we are now in the H section, and we have successfully found the word house. This is essentially binary search, and you can tell that it is efficient because we only performed about 4 operations to find what we were looking for when our input had 26 elements. As our input size grows, the number of operations that we will perform will not grow proportionally, but it will grow logarithmically. If we had an input size of 4,000 elements, it would only take us about 12 operations to find the element that we are looking for. This is really powerful and really efficient. There are different ways to code out our binary search algorithm, but we will be coding it out in a recursive way. Recursion is an incredibly important concept to understand and be able to implement in programming. This binary search algorithm is the first algorithm that we will be using recursion in, but we will also be using recursion in other algorithms throughout this course to help you get a good grasp on recursion and how it works. Before we begin coding out our binary search algorithm, let's learn about recursion in the next video. See you there.